Welcome to Integrating with Amazon DynamoDB using Delphi CData Enterprise Connector webinar. My name is Paweł Głowacki. I'm working for Embarcadero as sales consultant, and today we are going to focus on connecting your Delphi and C++ Builder applications using the newly added enterprise connectors to one of the available services, and specifically Amazon DynamoDB. So Amazon DynamoDB is one of the leading NoSQL databases, and it's available to integrate through enterprise connectors. So why DynamoDB, and why I have chosen this special service as an example? So DynamoDB is a NoSQL cloud service available from Amazon Web Services. You can use it either as a standalone or also use it as a local database service so you can download a local version for testing and development. What makes it really interesting is that it is very fast. So this is specifically something that is characteristics of NoSQL databases, because they trade some of the flexibility and some of the ACID functionality, atomicity, and the typical SQL characteristics, but to get a super speed. So you can have a single millisecond latency with operations at any scale. So you can specify when you provision the tables in DynamoDB what is the throughput that you want to use. So you can get to the single milliseconds latency, so that's very interesting. Let's have a look on the website of enterprise connectors to learn more about these connectors, and in this presentation I'm going to focus on just DynamoDB connector. If you navigate to www.embarcadero.com/products/enterprise connectors, you can learn more about these new enterprise connectors that have been recently made available by Embarcadero with the partnership with CData, which is a company that specializes in building and architecting very performant drivers to different systems. So one of the offerings, one of the types of the drivers that CData offers now are fire duct drivers. So what is special about these new enterprise connectors is the fact that different services that you might want to integrate typically provide different APIs. So you don't need to learn different APIs of different services. What these drivers provides is a SQL 92 interface, so you can use a familiar SQL statements like select statements, insert statements, and so on, to integrate with all kinds of services. So this is also available as implemented technically as a fire duct driver, so you can use a standard fire duct components like connection components, like query components, like stored procedures, like metadata information components, to work with all kinds of services. So one of the examples of the services that are available through these new connectors is DynamoDB. You can see the whole list of different applications, different systems that you can integrate with using those enterprise connectors. The offering is in two different variants. There is an enterprise and enterprise plus that contains more systems. DynamoDB is available in both of these offerings, so it's enough to have just enterprise subscription. So how it works is that you can download the trial version of these DynamoDB drivers from inside of Delphi or C++ Builder using a Getit package manager. But if you want to use a retail version, then you can contact Embarcadero or one of its partners and purchase separately a serial number or license to use those connectors. So you get just one serial number and you have access to all the connectors for the duration of the year, so you can build applications, you can deploy them, you have access to all the new drivers that are being added. But after this 1 year, your application will still work. So even though you will not longer have this maintenance of or subscription, which we it's a good idea to have it perpetually, but your applications that you have built will continue to work even if the subscription is over. So this is a very interesting and very powerful and productive way of integrating to sometimes maybe very exotic services. So one of the services that we want to work with today is Amazon DynamoDB. So it is a NoSQL database. So it's very different from a traditional databases, SQL databases, because it's schemaless. So when you define tables, you don't need to define upfront the names and the types of all the columns before you can work with it. The only thing that you need to specify is the primary key, and then you can different items that corresponds to records in a database can have a different attributes that corresponds to columns. So you can have a different items but with completely different attributes. The only thing that they need to have in common is the same type of a primary key. Also, this really is one of the fastest databases on the market. So you don't specify a size of a database or database table, but you rather specify a throughput capacity, and the more capacity you have, the more you need to pay. So it's on a pay what you use basis. Also, something that was relatively recently added is the Amazon DynamoDB accelerator, which makes it possible to go from milliseconds to microseconds response time. So this could be very interesting in situations like when you have a high-end real-time multiplayer games that you really need to have these very few milliseconds to generate a next frame, but still you need to contact with the system and to see the state of the game and see what you need to display. So there are many different examples, and this is very interesting to see that this is used. So there are different ways of integrating with Amazon DynamoDB. So you can use a language SDKs. So under the hood, those language SDKs, and also the connector is also fit in this category, is using the REST API. So there is a REST interface that you can learn about, and there is also interactive console, so you can do everything, the management of the DynamoDB using a web console. But there is also a command line tools that also are very handy to integrate, to work, to manage the different Amazon web services. So what are the first steps to get our Delphi applications to work with DynamoDB? So first of all, you need to have your own DynamoDB account. So maybe I just for a moment will get out of this and just show you how you can set up the DynamoDB account. So there is something called Amazon free tier. So you can create a free account. You still need to have a valid credit card, but for certain services that are part of the free tier, you will not be charged, so you can play and see if this is something for you. So one of the services that are also available as part of the free tier is the DynamoDB, so you get 25 gigabytes of storage, and also some of the write and read capacity, so you can start playing with your applications just without paying anything up front. So that's a first prerequisite. You need to have a Amazon account. And once you have your account, you can use an Amazon Management Console to log in into the to the console, and then you can just start playing with DynamoDB. So this is a list of different web services available from Amazon. One of it is DynamoDB. There are also other interesting services, like for example EC2 for virtual servers in the cloud, or Lambda for creating a serverless applications. Here we are going to focus on a DynamoDB. So click on DynamoDB, and here we have a certain dashboard, and you can see I have been already playing with it. So I have a number of different tables created for it. So right now what I'm going to do is to first create a table, and then I'm going to populate this table with some sample data, and then later on we are going to access this data from inside of the Delphi applications and the RADStudio IDE. So the first thing is to create a table. So I'm going to use sample data, and this is part of the documentation here available online. Is some sample data files and some steps how to create a table and how to populate it with data. So here we have a sample, two use cases: product catalog and forum application. So we are going to use just this first one, a product catalog. So when we create a table, product catalog, we only need to specify the primary key because it's schema-less. So here we have also the location of some test data, so we can download sample data, and it will just download a certain JSON file that we can use for loading data. So first let's start with creating a table. So I'm going to create a product catalog table. I have already created two of them, so I'm going to specify the third one. So product catalog, and that will be product catalog 3, and the partition key is ID, and the type is number. Also here we have a possibility to add a sort key, so that's another way of creating databases. There are certain resources available in the internet that explains best practices of architecting performant NoSQL DynamoDB solutions. Basically, the data in DynamoDB is stored in SSD drives, and this partition key is used by the internals of the DynamoDB engine to calculate a hash value that then it's basically the size of the physical location of individual data. So it's a good idea to have to select as a partition key some value that is properly distributed, so you will get a better performance. But that's probably beyond the scope of this presentation, but that's something that is good to learn if you want to really do it for real. So I can create a product catalog right away and do a create. Okay, so I can see that my table is being created. So in order to load data, test data here, I can just click on load data into the table, and here we have one of the easiest way is to actually use a command line tools. So this is a set of the command line tools for Amazon that you can use for Windows, Mac, or Linux. Here we have I can just download a 64-bit version of these tools. So that would download for me a installer. you can see I have a number of those installers already downloaded. It's a very small download. You can just open it in the folder and and run it. So let me show you this. I can just click on open. This should run the standard installer, and this is a useful tool for managing different Amazon services. So something that we also going to use to load sample data. So here I can click on next, accept the agreement, and it will install it in the program files Amazon CLI. I'm not going to go further because I have already installed this command line interface. Okay, so the next step really is to generate special security credentials. So in order to use the command line interface or interact with Amazon Web Services through REST APIs, we need to have a certain keys, the two strings. One is a key, one is a secret key that needs to be embedded in every HTTP request we send to DynamoDB. So there is a special service here. If we go to the services, I'm already logged in here. I have my account and I can go to the my account and management console, and here in the category of security, identity and compliance, there is an identity access management service that I can use to create a user, and as a side effect I'm going to create credentials that I will need to communicate with Amazon. So I can here add a user. This could be any, like for example Delphi, DynamoDB user, and it's important to make sure that I check the access type to programmatic access because I want to generate access key and secret access key. And the security is a very important part of any cloud services. So the model here is that we communicate with the service on behalf of a certain user. So the certain user will have a access to a certain services. So here we have a Delphi DynamoDB user, so we only need this user to be able to access DynamoDB and not any other services. So here we can specify to attach existing policies directly to the user. The other option is to put the user to the group, so we have a more functionality. And here I need to specify which policy I want to add to it. So here we have Amazon DynamoDB full access, so I need to check this policy. So I can now use this policy to grant this user that I'm creating full access to DynamoDB. On the next page of the wizard I have a review, so that will be my user, and it will have all access to DynamoDB, and I can create a user. So in a moment I should see a screen that will show me the access key and the secret access key. So this is the only moment that I'm able to actually obtain the password or secret access key for this user. And this is intentionally. You can create as many users as you want, and it's a good practice to rotate them. And if I don't, I can easily show you this access key, because at any moment I can disable this user. So that's how it is. And what is important, I need to get this access key and the secret access key. I can download them as a CSV file, or I can just copy these two strings to Notepad, because I will later use it. So once we got this, we can go to the next step, and let's see what is our next step. We have just created the user, and we can now jump into the process of loading sample data. So here we have a topic, also here load data, and we can use AWS command line to request items. So after I have extracted the sample data, there is a product catalog JSON file as part of it, and now I need to execute this statement from command line. So my command line is already running, and you can see this is the operation that I need to execute to load data. In fact, I have already added this data to these tables. I'm not going to run it. Really, after installing, the first thing you need to do is to do the AWS configure, and then you can specify the access key, you can specify the secret key, you can specify the default region. This is also very important where we are going to work. So in the Amazon console, in my account, so here in the account, if I go back to the DynamoDB, I can see that in the top right corner I can see all the different regions. So it's important to make sure that I'm creating these tables in a specific region, and so I can see the different tables are in different regions. Maybe it's not viewed here, but I know they are all in Ireland. So it's important when I'm working with this to specify the proper region and also default output format JSON. So I don't change anything, so I just show you this, but here I can just go and execute this statement to load data into the table. So once I'm done with it, I can go again to my console and I can preview the different product catalog items, and this is how it looks like. This is very interesting because you can see that different records, or in NoSQL different items, they have a different attributes. So there is some bicycles with different attributes like bicycle type, color, and there are different books that have different attributes like authors, dimensions, or ISBN number. So this is typical for NoSQL databases. The only required attribute is the ID that you need, that it identifies the given record. Okay, so we have already gone through the first step. So now we have now data. We have created an account. We have created the table. We have populated with data. We have credentials. Now we can go to Delphi. Okay, we are now inside of RADStudio, and in order to install the driver, the FireDuck driver or enterprise connector, you need to go to the CData website and then download and register appropriate setup program. Okay, so here we have we see the CData website with DynamoDB FireDuck driver. There are other drivers available here, so you need to navigate to the driver that we want to use. So you can see that CData also offers other types of drivers, not necessarily FireDuck, but they specialize with communicating with also using other technologies. So here we have an Amazon DynamoDB FireDuck driver. So you need to separately purchase that serial key, and then you need to enter it here, product key and your email address. So during the process you will download a setup.exe file. When you run it, you will be also asked to register online for the first time. When you install the first connector, all subsequent connectors you don't need to register because you are already registered. And after you have installed successfully this driver, you should see this driver installed inside of the RADStudio. If you just want to give those drivers a try, you can use a Get It Package Manager. So we have here the connectors category, and inside of the connectors category you can just quickly go to the DynamoDB. So this is this driver. I could have installed a trial, but instead of using the trial You can just click on it and accept the EULA, and yeah, then I'm not going to continue because I have already installed the commercial driver. So here, if everything is okay after the installation, you should find in the Data Explorer the new CData DynamoDB data source, and the first thing that you want to do is to create a new connection. So you right click on this one, select add new connection. Here you can specify the name of the connection. I have already done it, so I have one connection specified, DynamoDB1, and we need to configure this connection. So right click on the connection, select modify, and here we can enter our access key and a secret key, and also the region when we keep our data. Also, there are many other parameters here that controls how the drivers work. So there is a documentation that comes with the installation of the driver. Also, this documentation is available online, where you can actually see how different parameters here controls the operations of the FireDuck driver. The first thing is to click on test to verify the connection is established successfully, and we are good to go. So if we open now this DynamoDB node inside of the Data Explorer, we can see all the different tables that are here represented as a standard SQL table. So for example, my product catalog will have a primary key and different attributes, so we can preview this data directly from here. So this is exactly the same data that we have seen on using the web console. What is also interesting here to note is that there are two standard stored procedures, one for creating table and one for creating the schema, that you can use like a standard FireDuck stored procedures to either create a table, so we don't need to do it manually, we can do it in code, or create a schema. The schema is also very important because how NoSQL databases work is that there is no schema, but for FireDuck and the SQL concepts, you need to have a schema. So there are two ways of operation. So maybe it's a good idea now to show you how the online documentation looks like. So here, if I go back to my FireDuck components, here we have different interesting things to learn. So this is a locally installed, you can see local help file, so you can see certain things like things that we have already done, creating account, creating credentials, writing some basic access code. We have not done it yet, but also very interesting information about how this works. So here we have two ways how the driver works. There is an automatic schema discovery and custom schema definition. So basically the driver itself, and this is controlled by row scan depth. So by default it will look into the first 50 records or items in the table, and it will try to it will create a automatic schema that represents the items that it has found there. And there are also two additional parameters on the connection: flatten arrays and flatten objects. So this is how you can basically specify what should happen with attributes that contain JSON themselves. So here, for example, we have a court attribute that is an array of two double values. So to make our life easier to work with code with this data, we can set the flatten arrays to true, and then this field will be translated into the two float values. There is also interesting concept of the JSON functions. So these are the extensions to the SQL language that the driver knows about, and you can use them to easily extract different elements of JSON from inside of the attributes that are part of the table. So let's maybe start from just creating a simple table. Okay, I'm going to go back here. So this is my table in a Data Explorer. I'm going to create a new VCL Forms application in this case, and I'm going to just take this product catalog, drop it onto the form, add a data source component connected to the query component. So here we have a query, and this we can preview the just a standard select star from product catalog. We can execute it from here to see that it works as expected, and we can very quickly build a simple application to work with data. So it's not a rocket science, something that we've been doing since Delphi 1. I'm going to add a checkbox here to make this product catalog table or query active. So here I can change this to active, okay, like this. And if then my product catalog table is active only if my checkbox is checked. So in this way I will be able to open and close the table. I need to add two more elements, so I'm going to add a TDB navigator, so I can put it on the panel, and I can add a TDB grid, well-known component. I can use quick edits to align it to the client, and I can use a shift key to select both components and to connect them in one operation to the data source. So in this way I can now save it, unit 2, project 2, great names, so I can run my application and I can verify that I can see data from the underlying table. So here we see that we can, for example, change the author 3 to author 4. We can pause this change, and if we just communicate again, we can see that we have a read-write access to the underlying data. So this is very powerful, but it's obviously it's just a beginning. We can use a different connection properties parameters to work with different aspects of a database. So for example, we can play a little bit with this scanning option. So we see that there are 5 items that are with information about bicycles and 3 items with information about books. So by default, if you open this the parameters, you can also see it from here, from the object inspector. There are many different operations. So there is this these options to flatten arrays and flatten objects, but also we have this option to specify this depth, row scan depth. So instead of 50, let's make it 3, and let's see what will happen if I now run the application again and open the table. I should see that the fact is that I have 8 records, but I have only the certain columns that are only applicable to bicycles. So you don't see the book size or book ISBN number. So it has used just the first 3 records to infer the schema. So that's many other options here. Also, what is interesting option is the support for caching. So this component can work also in the offline mode. So there is a special offline property that I can set to true. There are some cache metadata and cache data. I can specify the database, so that will be a local file with a cached data. So this is all very nicely described in the documentation of this driver. Let me jump back here again to my slides. Yeah, I have already done this, and want to show you also these JSON functions, how they work. So I have another sample project here, and that will be not project, but it is I need to open it from my existing projects. It's called students. So basically what I have done, I created manually this table that was described here. So it's a table with different student information. So I have just used a web console to create a students table with a primary key called name and the grades attribute that contains this array of scores. And I can use different extensions to the to SQL language to use this extract a certain element from the array. I can calculate how many elements are in the array. I can find the total of the elements, a minimum or maximum value. So this is very straightforward. This demo basically again is just the same connection, but this time we have a query component that connects to the students table. We can execute it, so we have just a Smith, and the attribute is just a JSON array. And here if I call execute, I'm just clearing the SQL and taking the currently selected SQL from the combo. In the combo box I have a different queries that I have copied from the documentation. So now I can just run this demo and see how that would work. So I can execute it and it should work. Okay, so I have, if I want to, for example, have the number of grades, execute, and now I have 5 grades, and so on. So that's interesting extension to the language. One more demo that I wanted to show you is the working with some sample data. So as part of the online documentation, we have different test data. So here we have also the movie data. So if you want to work with different SDKs, so there are different examples in how to work with movies data and how to work with .NET, Java, JavaScript, Node.js, and other SDKs that are available. All those SDKs are using the same movie data. So what I have done, I have extracted a small chunk of this movie data because it's quite big, and the objective is to insert this data inside of the table. Let me quickly run this movie sample. So I have written some code to read data, the JSON data, movie sample data from a file, and this is how it looks, just converting to the string. And here is some processing. So let me very quickly show you what's here. So there is a special unit here that models an individual entry, individual item in the movies database. There is a movie rex. So this is a generic list, and also this has a class function that is a kind of a constructor like that takes a plain JSON and returns a generic list of recs, and these records can be then programmatically inserted into the table. So let me show you how this works. So first of all, you can use the query components, but this time instead of using Dynamo connection component, query component on the form, it's a better practice to put it on a data module. So my data module has now insert movie and insert movies. So this is two possibilities how you can enter data into the database. So you can use just a standard syntax when you I have a parameterized query. You can see how it looks like. It has just insert movies and a standard SQL syntax for an insert statement, and in parameters I need to specify the types of these parameters. So now I can just programmatically assign to these parameters and execute query to insert a new item. But it's also possible and more efficient to use a so-called RIDML syntax. So you can use an array size property. So instead of executing insert statements one by one, you can put them in a batch. So you specify how many params you should have, and this is a two-dimensional array of parameters where you specify not as integer but as integers, and then you specify which element, and after you have assigned the parameters to all the records, then you can execute them in one operation. So under the hood, these statements translate into this REST API batch insert items that we've been using to populate the product catalog table. So these are some of the samples. It's quite big, and in this presentation I just wanted to give you a feeling what it is to work with DynamoDB in Delphi. So it's a very interesting technology, and with the new enterprise connectors, you can use a familiar SQL 92 syntax. You can use FireDuck framework, familiar components like connections, queries, and integrate with all kinds of these systems that are not necessarily databases, or maybe completely different systems, like for example Google Calendar or Salesforce or Twitter, and then you can look at these systems, these APIs, as if they were a traditional SQL relational database. Okay, so that's it for today. Thank you very much.